Hey, geometry students, it's time for another lesson, and this lesson is the second part of section 1.3 in your textbook. And in this lesson, we're going to be learning about midpoint and distance. So your learning objectives are that you can understand and use the midpoint formula, and that you can understand how the distance formula is related to the Pythagorean theorem, and use that to calculate the distance between 2 points in the coordinate plane. So, like this says, we are going to be in the coordinate plane. So first, let's go ahead and figure out how to calculate the midpoint of a segment, of a line segment. And the clue here is to take the average, and that is basically all you need to do. So you're going to take the average of the x's and the average of the y's. And if you just remember this little phrase, average of the x's and average of the y's, that is all you need to remember to calculate the coordinates for the midpoint of a line segment in the coordinate plane. So again, average of the x's, average of the y's. When I say average, I'm talking about the arithmetic mean. There are many different averages. There's mean, median, and mode that you've been introduced to. And there's different types of means. There's other types of averages. Okay, but when we say average, we're talking about the arithmetic mean. And so just a quick refresher, if you want to take the average of two numbers, just two numbers, let's say the numbers are 3 and 17. Well, what do? And everyone knows you just simply add those numbers together and divide by n. And in this case, n is equal to 2. N is the number of observations that there are, or number of data points that there are. So go ahead and add them together. So it's 3 plus 17 equals 20. Divide 20 by 2, and you get 10. So 10 is the average of 3 and 17. So this is the average that we're talking about. Okay, so in this diagram, we have a line segment, segment AB, and this line segment is in the coordinate plane. Okay, so that means that A and B, those 2 points, they're both going to have an X and a Y coordinate. Okay, and so for generality, for point A, we're going to just use x sub 1, y sub 1. Okay, and then for B, we're going to use x sub 2, y sub 2. So these subscripted numbers here are just to keep track of which x and which y we're talking about. Okay, so to calculate the coordinates of the midpoint, you simply take the average of the x's and the average of the y's, one step at a time. Okay, and so here is what the formula looks like. So this capital M stands for midpoint, okay, which is this point right here. And its coordinates, these parentheses, mean that this is the x coordinate and this is the y coordinate for the midpoint. Okay, and the x coordinate is x1 plus x2 divided by 2. So that is the average of the x's. And then the y coordinate of the midpoint is simply y1 plus y2 divided by 2. So you average the y's. Okay, so to get the midpoint, you average the x's and average the y's. So let's go ahead and do an example. So here we have an example. We have segment RS in the coordinate plane, and we're given the coordinates of both of those points, both of those endpoints. So R has coordinates 1, negative 3. S has the coordinates 4, 2. And we want to know what are the coordinates of the midpoint of segment RS. So the midpoint is going to be, I don't know, somewhere around here, but you can't just eyeball it, okay? You could just eyeball it. Remember, if this was horizontal or if this was vertical, then we could simply just use the absolute value of the difference, right? But because this is not horizontal or vertical, okay, we have to calculate where exactly the middle of this thing is. We have to use a horizontal and a vertical component, right? And so we're going to average the x's and average the y's. So there's our formula for the midpoint. The midpoint is the average of the x's and the average of the y's. So here we go. We simply plug in, okay, the x's. So x1, x2, so 1 plus 4. This 1 right here corresponds to x1. This 4 right here corresponds to x2. Okay, so 1 plus 4 divided by 2 gives you 5 over 2, 5 halves. And then here, this negative 3 corresponds to negative 3, the y1. This 2 corresponds to this 2 over here, y2. Okay, so y1 plus y2, negative 3 plus positive 2 gives you negative 1, and it's divided by 2. So the coordinates of the midpoint are 5 halves, negative 1 half. Okay, so 5 halves, you guys know that that is, okay, 2.5, and then negative a half, so it's going to be right about here. There, right there, and there's your midpoint. The coordinates of the midpoint are 5 halves, comma, negative 1 half. Okay, easy peasy. Now there's one other type of example that we're going to run through. And in this example, instead of finding the coordinates of the midpoint, you are asked to find the coordinates of one of the endpoints of this segment. So you have this segment JK, and it's sitting there on the coordinate plane. And you are given the coordinates of one endpoint, J, 1, 4, and you're also given the coordinates of the midpoint of the segment, okay, M, 2, 1. And we want to find the coordinates of the other endpoint, K. So we're just going to call these coordinates for right now X and Y because we don't know what they are, right? Notice that these are color-coded. Blue are all the X's, red are all the Y's. Okay, so how are we going to do this? Well, we're simply just going to use the midpoint formula again. Okay, so first let's go ahead and solve for X. Okay, we know that the midpoint formula tells us that the X coordinate of the midpoint, this thing right here, the X coordinate of the midpoint 2, that is the average of the X coordinates. So that is the average of 1 and X. So how do you average 1 and X? You just add them together and divide by 2. So that's the left side of the equation, okay, the average of the X coordinates. This 2 is this 2 right here, okay? So 1 plus x divided by 2 equals 2. Then we have a simple algebraic problem. Okay, solve for x. Okay, so what's the first thing you're going to do? You're going to get rid of this 2 right here by multiplying both sides of this equation by 2. So you're going to have 1 plus x equals 4. Then you're going to simply subtract 1 from both sides of this equation to give you that x equals 3. Okay, that's step 1. So that is this x right here. X equals 3 is this. That's 3. And notice 1, 2, 3. We can verify that it's there. We can also actually count. We can just go 1, 2. This is going to be negative 2. Okay, but let's go ahead and do the math. Step 2 is find the coordinate for the y coordinate for k. Okay, so same thing. 4 plus y over 2 equals 1. So 4 plus y over 2, so that's the average of the y's, is equal to the y coordinate of the midpoint. Okay. Same thing, let's just go ahead and solve, multiply both sides of this equation by 2. Let's go ahead and subtract the 4, okay, and then we get y equals negative 2. So here's your x, here's your y. Sorry about that. So the coordinates of k are these right here. K, okay, 3, negative 2. So there's your x coordinate, there's your y coordinate. Okay, so that is all you really have to do with midpoint. Easy. Now we're going to find the distance between 2 points, and the book calls this the distance formula. Now, one thing that I want you to get out of the habit of doing is many times in math classes, especially that are ones that are super heavy on calculations like pre-algebra and algebra 1, we're so used to just doing calculations. And so we're used to just give me the formula. Mr. Lee, can you just give me the formula and let me plug the numbers in and, do some calculations? Well, no, we're not going to take that approach. In geometry, we want to take a little bit more sophisticated approach to mathematics. And we want you to think a little bit more, okay, and draw upon prior knowledge that you have and really use your problem solving skills rather than just your calculating skills. Okay, so instead of just teaching you a formula, which is very confusing actually, and people always mix up what is it plus, is it minus, do we square root? Okay, it's actually a little bit confusing formula. I'm not going to teach you a formula. I'm going to teach you just to use what you already know, which is the Pythagorean theorem, also known as Pythagoras' theorem. So before I teach you how to find the distance between 2 points in the coordinate plane using Pythagorean theorem, we have to refresh our memories on what Pythagorean theorem tells us. So I have a super cool video which will help you not only for this lesson, but will help you for all of geometry, because Pythagorean theorem is something that you will use throughout the entire course of geometry. In fact, you'll use it later on in other math classes as well. So it's very good for you to stop right now and think about the Pythagorean theorem in a different way. So there might be a commercial to this video, but hopefully there's not. Oh, what happened? It didn't let me play the video. Here we go.
What do Euclid, 12-year-old Einstein, and American President James Garfield have in common? They all came up with elegant proofs for the famous Pythagorean theorem, the rule that says for a right triangle, the square of one side plus the square of the other side is equal to the square of the hypotenuse. In other words, a squared plus b squared equals c squared. This statement is one of the most fundamental rules of geometry and the basis for practical applications like constructing stable buildings and triangulating GPS coordinates. The theorem is named for Pythagoras, a Greek philosopher and mathematician in the 6th century BC, but it was known more than 1,000 years earlier. A Babylonian tablet from around 1800 BC lists 15 sets of numbers that satisfy the theorem. Some historians speculate that ancient Egyptian surveyors used one such set of numbers, 3, 4, 5, to make square corners. The theory is that surveyors could stretch a knotted rope with 12 equal segments to form a triangle with sides of length 3, 4, and 5. According to the converse of the Pythagorean theorem, that has to make a right triangle, and therefore a square corner. And the earliest known Indian mathematical texts, written between 800 and 600 BC, state that a rope stretched across the diagonal of a square produces a square twice as large as the original one. That relationship can be derived from the Pythagorean theorem. But how do we know that the theorem is true for every right triangle on a flat surface, not just the ones these mathematicians and surveyors knew about? Because we can prove it. Proofs use existing mathematical rules and logic to demonstrate that a theorem must hold true all the time. One classic proof, often attributed to Pythagoras himself, uses a strategy called proof by rearrangement. Take 4 identical right triangles, with side lengths A and B and hypotenuse length C. Arrange them so that their hypotenuses form a tilted square. The area of that square is c squared. Now rearrange the triangles into 2 rectangles, leaving smaller squares on either side. The areas of those squares are a squared and b squared. Here's the key. The total area of the figure didn't change, and the areas of the triangles didn't change. So the empty space in one, c squared, must be equal to the empty space in the other, a squared plus b squared. Another proof comes from a fellow Greek mathematician, Euclid, and was also stumbled upon almost 2,000 years later by 12-year-old Einstein. This proof divides one right triangle into 2 others and uses the principle that if the corresponding angles of 2 triangles are the same, the ratio of their sides is the same too. So for these 3 similar triangles, you can write these expressions for their sides. Next, rearrange the terms. And finally, add the 2 equations together and simplify to get ab squared plus ac squared equals bc squared, or a squared plus b squared equals c squared. Here's one that uses tessellation, a repeating geometric pattern, for a more visual proof. Can you see how it works? Pause the video if you'd like some time to think about it. Here's the answer. The dark gray square is a squared, and the light gray one is b squared. The one outlined in blue is c squared. Each blue outlined square contains the pieces of exactly 1 dark and 1 light gray square, proving the Pythagorean theorem again. And if you'd really like to convince yourself, you could build a turntable with 3 square boxes of equal depth connected to each other around a right triangle. If you fill the largest square with water and spin the turntable, the water from the large square will perfectly fill the 2 smaller ones.
Okay, so this water one, there's actually a cool video that I'm going to show you a clip of later on when we study right triangles and the Pythagorean theorem and the Pythagorean converse. I'll show you this, or you can just search it up on YouTube. Okay, so that is the okay, so that's the Pythagorean theorem, and what you guys know is a squared plus b squared equals c squared. Okay, and that it holds true for any right triangle where a and b are the legs and c is the hypotenuse. And so here it is right here, a squared plus b squared equals c squared. So you guys remember that, okay? So now how are we going to apply this? Well, you have this picture where you have this line segment, okay? And the segment AB, and we actually don't need this midpoint. That's irrelevant for right now. But we want to know the distance from A to B, the distance between 2 points in the coordinate plane. So what we're going to do is we're going to actually just use this line segment as the hypotenuse of a right triangle. Okay, so we're going to just drop a vertical here and then create a horizontal. And this distance from A to B is a combination of a horizontal component and the vertical component. Okay, in other words, to get from A to B, okay, there is some horizontal difference and there is also some vertical difference that goes into the calculation of the overall distance between these 2 points. Okay, so let's go ahead and do this. So a squared plus b squared equals c squared. Okay, so first let's look at the horizontal component for A. Okay, the horizontal component is this right here. How far is A from B in terms of just straight up horizontal distance? Okay, and it's right here. And so this little thing, we're going to call this A. Okay, the length of this red line segment, we're going to call it A. And it's also known as capital A, capital C, the distance between A and C. So this point we're going to call C, and I'll show you why in just a moment. Okay, and so this length is just x2 minus x1, x2 minus x1. And to calculate that, because it's horizontal and because we're going to be on the coordinate plane here, you can actually just count. If these actually happen to end up as whole numbers, you can just simply count, use the counting method. Or even if they're not whole numbers, you can just find their difference. Okay. Then we're going to look at this vertical difference. Okay. And the vertical difference is from point B to point C. Okay, and we're going to call that vertical difference B, little b. Okay, and so that's the length of this line segment, segment BC. Okay, which is also BC, which is just the difference between this y value here and this y value. So you could just take this number here and just subtract it from that number, or subtract this number from it. Okay, so there is your A and B, and notice that we've made a right triangle, right? So this is going to be a right triangle because this is perfectly horizontal, this is perfectly vertical. So in the coordinate plane, we've basically turned this one line segment into a right triangle. And so now that we have a right triangle, we know that we can use the Pythagorean theorem, which tells us that c squared is equal to a squared plus b squared. Okay, and so therefore C is the length of this line segment AB, which is also just the hypotenuse of a right triangle. So C is equal to the square root, and here is the distance formula. And a lot of you are going to be tempted just to memorize that. And if you do, well, shame on you. But that's okay. I understand that many of you just like to stick to memorizing and regurgitating. I don't encourage that, okay, at all. I think that it's time that you need to get out of that habit and mature in your mathematical thinking and processes and approach this with deep thinking and problem solving and not just memorizing and regurgitating. But I still know that some of you are going to insist on memorizing and regurgitating. And I'll tell you what the common student errors are. The common student errors for students who try to just memorize this and just brute force, regurgitate, plug in the numbers, is that they always, under the stress and pressure of a final exam, will confuse this plus with these minuses and these squares with this square root. Okay, so I'm just warning you, this is the distance formula, but do not memorize that. Okay, it is a waste of time. Okay, instead, think geometrically, think more visually. Okay, use your problem solving skills. If you're asked to find the length of this line segment AB in the coordinate plane, just realize it's the hypotenuse of a right triangle. Again, you can simply just count, use the counting method to figure out the horizontal component, or A, and just count to figure out the vertical component, B, and then just use C squared equals A squared plus B squared. Okay, so let's go ahead and do an example. So your school is 4 miles east and 1 mile south of your home. So we're saying that your home is represented by this point here, the origin. Okay, so 4 miles east and 1 mile south, that point is S, or your school. Okay, so your school is sitting at 4 comma negative 1. A recycling center where your class is going on a field trip is 2 miles east and 3 miles north of your home. So here's your home, 1, 2, 1, 2, 3. There's the recycling center denoted by point R, which is at 2 comma 3. Estimate the distance between the recycling center and your school. Now that is what the authors of the textbook asked you to do. Okay, I added this sentence, give the exact distance between the two. So we're going to do both. We're going to give the estimate and we're going to give the exact distance. You have to know how to do both of those in this class. And most of the time in geometry class, most of the time, not all the time, but the vast majority of the time, your teachers are going to insist that you give the exact distance, okay, or give exact numbers, exact answers, okay? But sometimes in the real world application of things, sometimes, depending on the context of what the problem is, sometimes you actually do need to estimate, okay? And so an estimation is where you're rounding, okay? So here we go. So first of all, what did I teach you to do? Let's look at the vertical component between points R and S, okay? The vertical component is A equals 4, okay? Now, how did I get that? Okay, I just dropped a vertical here and I literally just counted 1, 2, 3, 4. Now, technically, what did I do? I did this Y value here minus this Y value there and took the absolute value of that difference. But really, you can just think of it as counting. If you're visual, just drop a vertical and just count 1, 2, 3, 4. So your vertical difference is 4. Now let's analyze the horizontal component, or the horizontal difference, okay? And that is 2. Just count 1, 2, okay? Technically, what we're doing is the absolute value of 2 minus 4, okay? Finally, we just use the Pythagorean theorem, okay? So we know that this length, this distance, RS, is equal to the square root of A squared plus B squared. And so just plugging in A and B, we know that RS is equal to the square root of 4 squared plus 2 squared. And evaluating 4 squared and 2 squared, we know that RS is equal to 16 plus 4, or RS is equal to root 20. Okay. Now this is where the difference between the exact answer and the estimation, or the approximated answer, comes into play. Okay, so from root 20, okay, root 20 is equal to 2 root 5. Why? Because 20, when you're simplifying radicals, remember that the first rule of simplifying radicals is you cannot have any perfect squares in the radicand. And so root 20 is the same thing as the square root of 5 times the square root of 2, square root of 5 times the square root of 4. And square root of 4 is simply the 2 that comes out of the radical. Okay, root 5, well, 5 is not a perfect square, so it stays underneath there. And now we've simplified root 20 to 2 root 5. We can't simplify this any further. Okay. The approximated answer is where you would just simply put in square root of 20 into your calculator and you would round off. Okay. And so you would get approximately 4.5. Now, when you're approximating, okay, and you're rounding, you need to use this symbol right here. Okay, the equal sign is 2 squigglies, and that means that it is approximately equal to, not exactly equal. Okay, now are we done? Think about the previous lessons. Think about what RS represents. RS represents a length of something, a length of segment RS. Okay, and so you would have to put units. Ooh, I actually made a mistake here. So I put units and units, and I was trying to teach you a lesson, but I made a mistake. Can you think of what the mistake is? Okay, so instead of just using the word units, okay, let's think about what RS actually is. In the context of this problem, it is the distance from school to the recycling center in this hypothetical example. And that distance is not measured in just units, it is given in miles. So this would be 2 root 5 miles. This should be miles, and this should be approximately 4.5 miles. Okay. And actually, the best way to answer this would be to write a sentence to say that the distance between the recycling center and your school is approximately 4.5 miles or exactly 2 root 5 miles. All right, so distance, okay? Calculate the horizontal component or the horizontal difference. And you can just do the counting method with that. Calculate the vertical difference, okay, or the vertical component. Okay, there's your A, there's your B, or you can call this B and call that A. It really doesn't matter. And then simply just use C squared equals A squared plus B squared, the Pythagorean theorem, to solve for C. So let's review. There's 2 things we learned. First thing is the midpoint. Midpoint is the average of the x's and the average of the y's. Okay. Distance. Okay. Look at the horizontal difference, figure out the vertical difference, and then simply plug those in for A and B into C squared equals A squared plus B squared. Guys, that is all I have for you. I hope you enjoy your practice, and thank you for listening.